Okay, so this is a really good example of a question that involves solving a system of linear quadratic equations. So in this question, we have two objects, a circle with radius 5, given with equation on the left, and we have a line given with equation on the right. My goal here is to prove that the line is tangent to the circle, or in other words, it touches the circle at only one point. So I'm going to have to find that point algebraically. So the underlying knowledge that you need to know for this type of question is that in order to solve a system of equations when there's two equations, or pardon me, two variables, you need exactly two equations. So getting starting here, I'm just going to make a substitution of variables. And so in the equation on the right here for the line, I'm just going to find an explicit expression for y in terms of x. Or in other words, I'm just going to isolate the y. So taking 3x to the other side and dividing through by 4, you can see now I have an expression for y. Okay, so now on the equation on the left, I'm going to rewrite it here, x squared plus y squared. But I know another version of y is over here, all in terms of x. So that's the goal that I want to accomplish anyhow. So I'll make that substitution. Sorry there. And y is being squared here, so I'm going to have to wrap brackets around that. And that's all equal to 25. So from two equations with two variables, I've now reached this spot here where I have one equation and one variable. Now I can solve for a value, an actual number. So on to the next step, and in order for me to expand this bracket, I'm going to have to FOIL the binomial. So I'm going to do that over here on the side. Okay, so I'm just using FOIL, 25 and 25. 3 and 25 will make 75, and it happens twice because it's a perfect square. So minus 150x, and then 9x squared from those two 3's. Okay, so that's in the numerator here after this expansion. So I'm just going to copy that down here. And I can't forget to square the bottom. And that's all going to be equal to 25. Okay, so now in order for me to solve this equation, I'm going to just have to get a common denominator throughout. And you just need to use some knowledge of rational expressions, and you're very close to the solution. And 25 is exactly 400 over 16, so this question is working out nicely. So now that everything is above a common denominator, it makes sense that 16x squared plus 9x squared minus 150x plus 625 is all equal to 400. Equivalent denominators implies that the numerators now need to be equivalent. Now in order to solve this quadratic, I'm going to have to put everything on one side of the equal and make that equal to 0. So 625 minus 400 is 225. So starting to factor here so I can solve the problem. 150 divided by 25 is a 6x. 225 divided by 25 is a 9. That's all equal to 0. Okay, this factors as x minus 3 equal to 0. Okay, so now I know my solution is x equal to 3. So plugging 3 into my formula above, in the circle equation, 3 squared minus 25 equals minus y squared. So 9 minus 25 is 16, negative, but there's a negative on the other side, so 16 equals y squared. I think it's obvious now that y is 4. Okay, so there's my solution. That is the point on the circle where the line intersects exactly at one spot, the tangent.